Welcome Extension 2 students. Let's look at this hard induction question from 1998 4 units question. Don't scroll away because it's very old. Trust me, it's valuable if you wait to the end and do it. So the question is here and you can pause to do it by yourself first. Okay, so let's start by reading the question. All these numbers are fixed and positive, and p greater than 1, q greater than 1, and p is this. So they are connected, p and q are connected. Now, what's the positive value of t that minimizes this expression? So f of t, this is a function of t, and this one should be a easy question. We should do. Obviously, we need to use differentiation to find the turning point. Now, if we differentiate the function, we get this, because here is we diff this to get 0, we diff this to get t, and we diff this to get minus s. So that's what we get. Oh, wait, sorry. Careless mistake. We diff this to get this. And then we equate that to 0, so we know that at this point is a turning point. And we can use the second derivative to show that it's actually a minimum turning point. Now we can do the second question, which is just a follow-up question. Show that for all t greater than 1, we show this. Now, because we already showed which value it minimizes, it's this value that minimizes. So for all positive values, it should be greater than this value. And we just plug it in after some algebraic manipulation using the relationship between p and q. You can get that it's equal to 0, so it's always positive. These two are quite easy. Now let's look at the third one. Proved by induction. It's the AMGM inequality. It's a very well-known result, and I think all questions involving this type of proving this is quite difficult, especially it's generalized. So let's do it strictly in the exam condition and do question 4 first, because you cannot do 3 and do 4. So let's try that. So it's asking us to show this, and why is it easy? Because if we have this result, I can show that we can move n to the other side to get this. Oops. Then we just plug in the values, and because if you plug in this xx1, this xx2, this xxn, and you multiply them all together, they all cancel out to be 1, so you know how to do it. Now it's fairly an easy question. You should be able to do it in your head. It's what I wrote is literally what I said. So let's look at the real spice, which is proving AMGM inequality using induction. So let's go. Never mind about method 1 because there's no method 2. Let the proposition be Pn. These are just standard. And wait, I did not do the base case, but anyways, you guys know the base case. Base case is, let's see, so n, what's n? So I suppose it's 2, so you don't really need to prove. You know that base case is just okay, never mind this, it doesn't matter. We all know how to do this, but let's just start the inductive step, which is the really hard one. Now we start from left hand side because it's easier to manipulate. You can try using right hand side if you wish, and you separate this because this is what you can use from the assumption, and then you can plug the assumption back inside, which is this. You plug it back inside. You plug it back inside to get the result of this. Now you have this. The real spice now is how can you reach to the right hand side, which is this. Now we must use, for this type of question, we must use the result from previous questions, which is this. So I strongly recommend you to write it out. Actually, you don't need to write it out because it's just above, but you can write it out. It's this, right? You need to do substitution, which is why it's the hard part. So very obviously, you need to use the right hand side. You need to use the right hand side here because it's 2 multiplied together and you want to show it's less than something. So what is s? You let s be this, you let t be this. Now you just need to find a value for p and for q. And for the p, I will choose it to be this, because I deliberately want to make the denominator k plus 1. So this is what happens if I plug it in. You just need some reverse engineering, and then you can find k is equal to k plus 1. And if you plug them in, you can get these results. And then it's the right hand side. So it's really the art of substitution. And that's the question. And let's, just for fun, you can read these comments on this question. Okay, so this one is basically showing why they made the question. You can read this for fun. It's probably not that much towards the exam, but it's still fun to read the weight arithmetic mean and weight geometric mean, and they also follow the AMGM inequality. And that's today's video, and hope you enjoyed it. Subscribe for more questions like this.